So now that you've got a chance to get a high-level tour through the history of concurrency and parallelism in Java, let's start getting more detailed. And what we're going to do now is take a look at some examples of applying Java's functional programming features in the context of a concurrent/parallel program. And this will be kind of fun because it'll introduce us to the particular style of example we're going to be looking at, and then we're going to take a look at how to program it using Java functional programming features. However, as you'll see, this approach, like everything, will always have pros and cons. So the pros are relative to the object-oriented way of doing things in classic Java. The cons are, of course, here to motivate the rest of the course, which will be focusing on streams and other techniques. Okay, so this particular program will search for a list of phrases in the complete works of William Shakespeare. And mostly I did this for two reasons. Number one, I'm a big fan of William Shakespeare. And number two, I just needed to have a big corpus of text to search. And so what better to search than the work of the Bard, which you can download in an open source form from MIT. They have all of his plays. I think he had something like, 37 plays and some big chunk of sonnets and other things. So it makes a good pile of data to look at, a good source of input. So the particular program is called the ThreadJoin test program. And what it does is it applies a bunch of these core functional programming features in Java 8. Things like method references, things like lambda expressions, functional interfaces, and so on, in order to create a bunch of threads to search for phrases in the complete works of William Shakespeare in parallel. So if you go to this link, you can see the program. And basically what it does is it spawns a bunch of worker threads, and those worker threads will basically search the works of Shakespeare for the phrases. And there's a main thread that's kind of the master of ceremonies that forks all the other threads off and then waits for them to finish. So we'll end up forking and joining in this particular program. And I'll kind of walk through this and show you how it works. This style of program is what's known as an embarrassingly parallel program. And this is a very strange phrase. And people often go, what the heck does embarrassingly parallel mean? And the best way to think about embarrassingly parallel is that you can do everything in parallel because there's no dependencies between any of the threads, the worker threads doing the actual tasks. So the best way to think about this, if you want sort of some grounding and maybe something you've heard on before, is an embarrassment of riches. So somebody is so wealthy that they're embarrassingly rich. Maybe, Bill Gates is embarrassingly rich, or Jeff Bezos is embarrassingly rich. I'm not sure how embarrassed they are, but that's a phrase that you often hear, an embarrassment of riches. So think about that when you hear embarrassingly parallel. It's like there's so much opportunity for running these things in parallel, it's embarrassing. And I think I've told you this before, my favorite mental model to think about when I'm thinking about embarrassingly parallel is a bank of washers or dryers where you can run all of your laundry in parallel, and you can just do it full tilt. You don't have to stop the washer and take stuff out and put it in another washer or wait for something to happen. About the only thing you need to do is you can't start drying until the clothes are washed, right? That's a dependency, but for the washing or the drying, those things can all run in parallel. So that's basically the way to think about this. So the way this works is we've got two text files, and one file contains the complete works of Shakespeare, so it's a very large file, and each of the works, like a play, like Hamlet or Julius Caesar or Macbeth or whatnot, is separated in the file by this little funny @ sign, because they didn't use the @ sign anywhere in Shakespeare, not surprisingly. They didn't have like, hashtag ghost of Hamlet, right? They didn't have any funny characters in Hamlet or Shakespeare. And so the way we're going to do this is we're going to use this method called getInput to go read this file, and it's going to split things based on this @ sign. And that's how we're going to end up with each of the different content that the content of the plays in a different string. So we're going to get back a list of strings where one string corresponds to the complete work of one play. Then there's also another file, which is the list of phrases. So before we had a list of works, the list of the plays, this is going to be the list of phrases we want to look at. And again, I don't know how much you've been forced to read the works of Shakespeare, but there's all kinds of great quotes that he said that have found their way into common use in the English language. In fact, one of the criticisms of Shakespeare is he wrote a lot of cliches, right? That's a joke because they're cliches because that's what we know him. These are things that he invented that we all say, like, all that glitters is not gold, or brevity is the soul of wit, or neither a borrower nor a lender be. And so here are the little programs, here's the little functions that split things up and make this stuff broken into the right pieces. So here's the getInput method that will read a file and give back a list of strings. And this particular example shows a few Java 8 streams features, which I'll just briefly mention. I won't talk about them much in detail yet, but this makes the example much more concise because we're using streams. So the first thing we do is we take the file and we go ahead and read we convert the file into a URI, so that basically gets a path name into the file system, so we can actually go ahead and open the file and read it. We then go ahead and open that file at that URI, at that path name, if you will. And then we read all the bytes in the file. So now we have a string that contains, one string that contains all the works of Shakespeare in one gigantic string. And then what we do is we take the splitter. If you go back here, remember the splitter was this thing, the @ sign. And we go ahead and split, or we take the splitter, which is the @ sign as a string, we compile that into something called a regular expression, and then we use that regular expression to split the string that contains all the content of the works of Shakespeare into something called a stream. And we'll talk more about what a stream is later. Think of a stream right now as essentially a flow of elements, where in this particular case, each element is going to be one complete work of Shakespeare. So we'll end up having a stream of strings where each string in the stream corresponds to the text in one work of Shakespeare. All right, so now we've got a stream of strings, and then we're going to go ahead and if for some reason, if someone misformatted the file, for example, one of the strings was empty, we're going to go ahead and filter out empty strings. So if there's anything in the stream that's empty, we're going to get rid of it. So that's what this does. And I'll talk more about what filter is later. Filter is this cool little intermediate operation that can be used to do transformations on the contents flowing through the stream. In this case, we only let things in that pass the particular condition. And the condition here is string is not empty. So we only let through things that are not empty. And then the last part here, and I kind of talked about this much earlier, but in the class when we first talked about streams, you collect the results into a list. So we take our stream of non-empty strings, and we collect them together, and we're going to return a list of strings, one string per work of Shakespeare. So that's what this particular method does. Pretty straightforward. If you were to compare this to the equivalent code written in more classic pre-Java 8 style, they would be more verbose. This is very declarative. Notice how declarative. Yes, sir? So what's you mean from the regular expression part up here? Well, it says. Oh, yeah, great question. So, yeah. All right, so pattern.compile. So pattern is a class that does a regular expression. And so if I'm not sure if you guys have taken regular expressions yet, but regular expressions are ways of being able to match on wildcards or match on strings. And so in this particular case, what it's saying is compile me a regular expression that will split this string according to the splitter character, which is just the @ sign, because that's what we use to separate those things. And so what it's doing here is it's compiling a regular expression, and then it's taking that compiled regular expression. It says, use that regular expression to split this string by the splitter, and then end up with a stream of strings, which are the, it took the one string and it split it up into multiple strings by the splitter, because that's the way the file is formatted that contains the works of Shakespeare, and then that becomes a stream of strings. So this is just basically saying compile the splitter into a regular expression and then use that regular expression to split this string into a stream, and then that stream of strings will be filtered to get rid of empty strings, and then that non-empty stream of strings will be collected into a list. So the cool thing about this, again, we'll cover this in great detail later, so if it still hasn't quite sunk in, that's no problem. What's happening here is we are transforming the stream such that we end up with a result at the end that's declarative in nature. So notice that there's no control constructs here. This is a so-called fluent interface. So we just kind of compose these things together and they make transformations. There's also other stuff that we'll talk about later too. There's the concept of an internal iterator that's kind of implicit in all this stuff, and it's moving the information through the stream. So you can kind of think this is like a pipeline with a set of transformations or filters on it to change it as it flows through there. Did that answer your question? Good. All right, so that's how we end up with a list of strings corresponding to the works of Shakespeare. Here's how we're going to convert the phrases into the file of phrases into a list of strings. So we take a file name, that's what this is. We go ahead and use this method called files.lines. Files.lines is another method that creates a stream. And it creates a stream by opening up the file and then converting the contents of the file into a stream of lines where each line is essentially a sequence of characters terminated by the new line. So, think of a line in a file, right? The thing that goes across from left to right and has an implicit new line at the end to kind of return the carriage to the beginning. So we end up with a stream of lines, one line per phrase in Shakespeare. Once again, we skip over anything that's empty, and then we collect this up into a list of strings where there's one phrase per string. So, to thine own self be true, or neither a borrower nor a lender be, or my horse, my kingdom for a horse, whatever your favorite Shakespeare phrase is. Now you've got this list of phrases, and of course we're going to use these phrases to search the works of Shakespeare to figure out where each phrase appears, if it appears anywhere. Okay, so that's basically how this works. And then we're going to transition to the fun part. Here is the main program that will create a new SearchOneShotThreadJoin object, so an instance of the SearchOneShotThreadJoin class, this guy right here. And that will then go ahead and run, and this will search for all the phrases in parallel. So you can see here that we've got our ThreadJoin test. ThreadJoin test is a Java class. It's got a string, which is the file name for the works of Shakespeare. It's got a string, which is the file name for the list of phrases. And then it's got this list of input and this, which is one string per work of Shakespeare, and then a list of phrases, one per phrase. And it's got a main method, and that's what this is, and this creates an instance of this particular class, and we're going to look at this class in more detail in a second. This is the class that does all the cool stuff with respect to concurrency. Okay, so that's just a quick overview, kind of giving you the big picture of what this program is trying to do.